Hello Internet, welcome back to, I don't know what we're calling this, Asteroids VR? That's a good enough working name for me. So this is the updated Asteroids game. I haven't really done, there's some work that's happened behind the scenes here, but it hasn't been that as much as you may think. You'll notice the planet is not just a untextured sphere anymore, there's some text there, and you'll notice Bloom is working. So how did I get that working? Turns out there's a few things that are going on. The camera we were using VTK or something, VRTK, and that was using an adaptive renderer, which doesn't work with Unity image effects. So we had, if we take that away, we get Bloom, which I think we're going to need for the game. So for now, we don't have adaptive rendering. That had to come out, but we get Bloom. It's kind of a trade-off. A few other things have happened too. You saw we were working with grapple guns previously. I'm actually putting that on hold for now. What we're doing for version 1 is going to be sort of an endless mode. There's not going to be any waves like you'd normally have in an Asteroids game, and there's not going to be any power-ups either, and the grappling thing is going to be a power-up. And so I'm kind of putting those on hold so we can get the core game done and then focus on those really cool features. So specifically what we're going to be doing is I've come up with a way that I think is going to solve our gravity issue. So what happens is when you start blowing things up, they all just fly away from you. And there's a problem to that, mainly being that they fly away from you. And so the battlefield or the field just gets bigger and bigger and bigger and bigger and bigger, and eventually you can't get everything. And so what we want to solve is we want to solve that problem. We want to make it so that there is always something there for you to catch, if that's the case. We also probably want to fix that just happened, because that is really disorienting when it happens. That was the auto orientation happening because an asteroid hit us. Anyway, what we're going to be working on today is we're going to be doing the gravity system. It is not going to be classic gravity. I want to make that very clear. Very much not real gravity, not even close. So what we're going to do is, you see this planet. This is a shader I brought in. It is sort of my own thing. I didn't write it for this channel. I wrote it like 3-4 years ago as sort of just a little project, and it does some really fun heated stuff. So we have 3 different temperatures, and we can do like a height map and make it warmer or colder or whatever. So I can like change the temperature and it just overheats, or lower it and it freezes over, and all the way in between. So we can kind of play around with that. And it gives you basic planets, but it gives you fairly interesting planets. You can kind of generate them how you like. So that's just a thing that we added. But what we're going to be doing with this is we're going to be adding a like plane around this. So what the algorithm is going to look like is, imagine a line coming out from our planet. So starting there at the center, it's going to come out, and it's going to kind of, I don't know how it's going to work, but there's going to be probably a repulsive force from the planet pushing things away from it. And then as you get near whatever the certain distance we want things to stay at is, the force is going to become 0, and then it's going to get higher and pull things back in. And so the idea there is we kind of want to keep everything in a ring around the planet right in this sweet spot. And so the way we're going to do that is we're going to actually use an animation curve and then bind that to the distance from wherever the center is, our planet. And then we can multiply that by some sort of scalar or vector, and that should get us the velocity that we need. So hopefully that works. And we're going to actually apply this to the player as well, so they kind of get clamped. And it's going to kind of feel like you just have less force the further in or out you go. The original idea was for you to be able to land on the planet, and I think we're still going to have that be a possibility. But that's also getting kind of pushed out because I want to actually I want to get something that people can play. So this is what we're going to focus on. So to do that, we're going to create a new scene and save it, calling it something fun. We'll call it just like gravity test. Sure. And then all we need are a few rigid bodies. I'm going to create a like planet center. Just make it a sphere and make it slightly bigger, like so. And then we need some asteroids. And we can do that with, let's just use a single cube for now. And we can just throw that there. And then let's say our sweet spot is 10 meters away. It's not going to matter here because we're going to be able to change this in our script. So I can throw it wherever I want and it should just work. If it doesn't, then we've got more work to do. So how we want to do this is we want a gravity, what do we want to call it? Constraint. Yeah, I think that makes sense. So it's going to constrain something using gravity to a specific place. So how this is going to work is it's going to close my file, so I'm going to reopen it. And then let's do a public animation curve. And I'll show you what these do. So we'll do an animation curve and we'll just call it the gravity scalar. Sure. So if I open this, we're going to just attach it to our cube, not to our sphere here, and give it a gravity constraint. And so this lets us do this. We can apply any sort of really fun like animation we want. And then what we're going to do is our X down here is actually going to be our distance. So I can like extend this. Let's say our time, we want that to be 20. So it kind of goes out. Then our curve gets very long. And so we can kind of use this to manipulate pretty much everything. Gonna kind of even it out a little bit, but you get the idea. So we want right here to be our sweet spot. So that's going to be right around 0. So it's not applying force in any direction. And it should almost just look linear like that. Sorry, that was my Vive controller is turning off. Anywho, we want it to kind of look like this. And this will be a little bit down. Anyway, point is we want the sweet spot to be right at 0. And then outside, we want it to be closer to 1. Inside, we want it -1. And so on. So that's pretty much all we need to do there. And you can use these for pretty much anything you need. So what we're going to do is we've already got this animation curve. I just need to attach it to a transform. And we're just going to call this the source. Oops. So now that we have our source and our gravity scalar, we also are going to want a rigid body. So I'm going to take a rigid body, just call it rigid body. Since we're calling it rigid body, I'm going to declare it as new, and this overrides the default Unity one that is deprecated. Then I'm going to require a rigid body component. Require component rigid body. There we go. Okay. And then let's just grab that here. And then what we can do is apply our force. So this is actually fairly easy. All we need to do is get the distance between our source and ourselves. And then once we have that distance, actually we need the vector difference. So let's do difference equals, and we're going to want it to be a vector towards. We want it to be a vector towards our planet. I think that makes sense. And so let me think how to do that. Take one, subtract the other, and we get a, what the hell? Okay, that was really weird. So anyway, if you take one vector and subtract the other, we are going to get a vector that is going to look like this, minus this. So should be that way. So if we take our source, we don't need a transform, we just need the position. Minus this dot transform dot position. We should get a vector. And so with that difference, we can then get another thing called the distance. Difference dot magnitude. And now that we have both of those, all we need is a normalized difference vector and the distance vector. So we're going to take our rigid body and we're going to apply force, add force. So it's kind of broken right now. The IntelliSense isn't working, so I'm kind of guessing in the dark on the method names. I don't usually remember them because you don't need to, and if you don't need to, I don't. Okay, it was add force. That's weird. So we're going to do the difference times the evaluate. We're going to need to evaluate here, but we're also going to need a time delta. So we're going to have the difference normalized. So we're going to stick a normalized vector in there. And then we're going to multiply that by the time delta. So per second, we want to move at whatever this speed is, times our animation curve, times the value that results from the distance plugged into our evaluation or our animation curve. So if we take a gravity scalar and we multiply that, or we evaluate that with the distance, this is going to take a normalized vector towards our center. It's going to give us the force over time, which is what this time delta is for. Then it's going to scale that by whatever our scale is, and that we can scale that with distance. So theoretically with this, if you were really dedicated, you could probably come up with something fairly realistic. Still wouldn't be totally realistic because gravity is based on mass, and this doesn't account for that in any way. But you could get it pretty close. There's better ways to do it if you actually want realistic gravity, because it's not that hard to solve for that. But what we want here is we want that ring around the planet, and this is going to get us that. At least I hope this is going to get us that. So what we can do is set our source equal to our sphere. We're going to need a rigid body here. And then turn off gravity because it doesn't need it. It's going to be applying its own gravity. And let's see what happens. So it looks like the sweet spot is sort of right around, what is that, about 9? So it should move in a little bit if we did this right. And if we didn't, then it's gonna not work right. Oh. So it is moving in, but we may have made it a little bit weak. So just, oops. I set the mass to almost 0, so the force of 1 was a little bit stronger than it needed to be. I was just going to tweak the mass just so we can get it to kind of move faster. That's not really that much faster, but you get the idea. It's kind of pulling in, and we should see it kind of slow down once it gets past there. And hopefully it'll come back. Does appear to be slowing down, that's good. And so what this is doing is it's sort of keeping it right around that point. And so if we really want to have this work, we can actually just edit this, change the value up to like 9.8. And then we can also edit this one and set the time equal to 0 and this down to negative 9.8. And now we get something a little bit stronger. And now it should kind of seesaw its way back and forth in there. And frankly, this is fine. it's totally fine that it is kind of staying somewhat in the middle there, because what we want is we want it to stay here. And so even if it kind of comes out, that's better. We just don't want it to go too far out. And so we can actually, like, if we want, we can actually tweak this curve. So I'm gonna insert another point here, grab, oops, that was wrong. There's gonna be a way to, yeah, do something like this. And we can actually do something more like this. No, let's flatten things out. So this is, what I'm doing is I'm kind of tweaking these values, and I'm making it so that there's a bigger range in the center where very little gravity is applied. And so this is going to widen out that ring of asteroids. So I can stop this, reset everything. So we're going to set this down to -9.8, 0, and then kick this up to 9.8 and 20. So it should center right around here. Then what we can do is we can add a few more of these. And I'm going to offset them just a tad. And hopefully we'll get some collisions going and some other fun dynamic stuff. And this isn't going to actually cause a ring at all. This is going to cause, I guess, everything to kind of just stay around this circle. So it's going to cause more of just a circle around it, which isn't really what we want, but we can fix that. But for now, I'm just going to do bad stuff. So we're going to add a bunch more of these. What could go wrong with going way over the top? So that's exactly what we'll do. There we go. Sure. There's only like 25 of them. And so we should see everything kind of spread out to right around that circle. And it kind of does. So that's pretty much exactly what we wanted. The only difference is now we want to clamp everything down to a specific plane. And that thing is going crazy. Interesting. Okay. But it does work, and it does keep everything right around where we need it. So the next thing we want is we want a plane. So we want to clamp it to not just this, but we want to apply a secondary one around a plane. And this can be a second version of this, I guess. I guess that's probably the easiest way to do it. Yeah. Okay. So, trying to think if the best way to do it is to extend this or to build something else. Probably to build something else, but let's test this and just get it working, and then we can play around with that some more. So, just to riff on this, we need another difference between, actually, just the distance between, let's see, the distance is actually, distance y is just going to be our transform position dot y, because I'm going to assume that we want to clamp everything to the y-axis. We may want to actually arbitrarily create a plane, but that's going to be more difficult. And we could actually just do that using probably some like dot products or something. Yeah, I think a dot product would probably solve that. For now, I'm just going to plug in y, and then if this works, and then in the next video we can actually spread out and actually get a plane here that we can do that for it. So let's take our distance, and all we need to do is do pretty much the same thing. Add force around our vector3.up, our time, delta time, and our, let's see, plane scalar. And so this doesn't exist yet, so we're going to have to create another one of these. And this probably isn't a great idea because I imagine this is probably going to be super slow, but we can work through that. So we're going to have another animation curve that's going to apply just for that plane, so we can tweak both of those individually. So maybe you want a really tight ring, but you want it to be really wide. You can adjust that with this. So we're going to need to select all of these and create something like that. And then based on the distance, we can solve for this. So let's plug in -1. Well, let's do -2. There. So it'll be a little bit steeper. And hopefully that keeps things fairly straight. One other thing I'm thinking of, this distance needs to be distance y, but it doesn't, this won't work. Because if things go below the y-axis, we're going to plug in a negative value here, and I don't, well actually, no, we want that. Do we want that? Yeah, I think we actually do. Do we want that? No, we don't. Actually, yes, we do. Sorry. We actually do want that because we want this to be at -1. That doesn't work. We don't want that. Okay. How can we do this? Actually, no. This will work. Do we want it? No. Screw it. We don't need any of this. Sorry. I'm thinking more than I need to. We need just a float, and we can just do our plane scalar. And that's all we need there. And we can just multiply that by our distance. And then this will scale, this will be a linear scale. So it won't necessarily give us exactly the same thing. But the advantage of this is it's going to be faster and it's going to be easier to control. And it's going to handle negative numbers. The reason we don't need to handle negative numbers with our other thing is because you can't have them. You can't have something a negative distance away. It's just always a positive distance. So let's plug in like 5. Sure. I don't actually know what these numbers are, so who knows? I'm also going to move this out because that didn't make any sense. All right, let's see what happens. Now, hopefully, we should see things start to gravitate around the center, but it looks like our force is exactly the opposite of what we wanted, because there everything goes, and that's not good. Okay, but we can solve that because all we need to do is multiply this by a negative. And so I'm actually just going to make this negative. We can solve that here. And that's not how you do that. You want to select everything. So there we go, -5. And so this is saying move things towards center. And now we get sort of a ring. And it may take a while for things to kind of collect themselves because this is all physically simulated, but we're getting a ring around our planet. It's kind of looking a little bit bouncy right now, but these are all values that we can tweak with those, with that animation curve, and then with this. So I think this is good. I think this will give us something we can use. The next thing to add, which I'll do in another video, is we're going to have this actually rotate around. So there's going to actually be some force around this planet. So there, maybe we'll tidally lock them, but the planet is going to rotate. And so we want this entire ring to kind of rotate around the planet as well. So think asteroid belt or something like that. Because right now everything is just kind of stuck in its sort of place. We don't want that. We want to tweak things. So that's on the to-do list. But this is it for now. So I hope you guys enjoyed it. If there's anything else you guys want to see, leave a comment and let me know. And if you like the video, leave a like and I'll make sure to do more. So until next time, see you, Internet.